Good day, everyone. Our theme for this year's science project is Solar for Life or Recycling for Life. And we didn't just want to build any project which would be relevant to us as a school or a community. Considering the challenges of rampant power outage and exorbitant cost of power supply in St. Antonio of Padua, our noble school, a group of 4 junior scientists came up with the idea after a research made with the help of our teachers to use LED to build solar panels to generate power to address our said challenge.
During our research to bring out this project, we needed to ask ourselves some educational questions. Can LED be used to build solar panel? Yes, of course. LED can be used to build solar panel. Which component in the LED is essential in generating solar energy? LED contains silicon which produces electrical energy when struck by light. How can the solar panel be built using the LED? When LEDs are arranged in series and parallel on a strip board and exposed to sunlight, it will produce electrical energy.
This project became feasible through the help of the following materials: a light emitting diode. To be able to power a solar panel to power electrical gadgets, you will need 1,000 yellow LEDs, yellow precise. Also, you will need a super glue to avoid misalignment of the LEDs. You also need an abrasive, which is normally called a sandpaper. You also need a soldering iron to melt the solder. You also need a solder, as said, to also give a good contact or a permanent board between the terminals of the LED. You also need a multimeter to read the volts after finishing the solar panel in volts. You also need a cutter. Also, the capacitor here serves as an accumulator to accumulate or store the energy. Then we have the strip board, in which the LEDs will be fixed in to also generate the electrical energy and solar energy and convert it to electrical energy.
So as you saw earlier on, the power generated by the solar panel was able to light the red LED. But because the brightness of the red LED isn't that enough under the sun to be captured by our camera, we are trying to use some possible means to prove that the power or current is generated by the solar panel. So we'll first check the voltage of the solar panel using the multimeter. So as you can see, the voltage is now 0.00 volt. So you are now coming to connect the solar panel to the multimeter to check the voltage it will generate. So as you saw, it was 0.00 volt, but now it is now about 2.87, 2.995, 96, 97. It's almost even 3.7 volt, as you can see. The solar panel itself can't store the energy or the power it generates. So in this case, a capacitor which serves as an accumulator is used to accumulate or store the energy the solar panel will generate. So first of all, we'll check the voltage in the capacitor first. So it's 0.00 volt. So as you can see, its current voltage is 0.01 voltage. Now we will connect the solar panel to the capacitor to accumulate the energy or the power it generates. The voltage in the capacitor was 0.01, but now it has been connected to the solar panel. So let's now check the voltage it is now generating. It's now 1.65 volts and rising up. The weather condition isn't that good, but still our solar panel is doing well or doing good to at least accumulate the capacitor. So this shows or proves that when LEDs are connected in series and parallel on strip board and placed under the sun to strike sunlight, it will indeed generate electrical energy.
At this juncture, we would like to take you through the procedures involved in building a solar panel. So it's a restart. So first of all, we take the strip board and to ensure that the strip board, they are not that good, but the strip board have the metal part and the non-metallic part. So I'll take my abrasive, the sandpaper, to just smoothen the metal part. Okay. So as she's doing it, I hope you talked about the LED. The LED has two terminals. They have the long one and the shorter one. The shorter part is the negative part, and the long terminals is the positive part. So are you done with the water? Yes. So we are going to start, and this is the strip board, and we are going to arrange the LEDs in a series form. Like we can even arrange it in a power form and a series form. But this experiment, we are going to arrange it in a series form. So. So we are going to leave a space. There are holes in there, so we are going to leave the first holes. Maybe you might put a silicon dye in there, and also so we are going to leave a space. So first, we start with the positive terminal. Just put it in positive terminal. Then to the next, you put in the positive terminal just to make it so here will be positive, here will be negative. So I hope you know the laws for interest issue. So we are going to leave a hole just to make it at least very comfortable or very spacious in converting of the energy. So I'm going to put in a positive part over here.
Go.
So with this one, we are arranging them in 4-4 to form a cell. So when we say in 4-4, it means that after doing this one, we leave 2 space to show that yes, we are arranging them in 4. So we leave 2 space and then arrange another one here, and then we leave another 2 space like that, and it goes on. 4 is 4. So I'm easy as C, 1, 2, 3, 4.
So our next stage, we just have to apply glue on the LEDs in order for them to be completely attached to the strip board to prevent misalignment. So by doing so, all the LED to be on the strip board. Then our next stage is we connect the LED so that there will be a connection between
the terminals of
the LED. So in this way, we will just have to leave the first positive side of the LED
of the cell. Therefore, so.
Then the last negative part of the cell. Then we join the rest. Join the positive side to the negative side in series form. So after doing so, when you use your cutter, you cut it to a desirable length you want. Then the next one you just pull up the first positive and the last negative of the cell. Then you join
also going to leave a space, just like we did for the first one.
For our next stage, you just have to use the soldering iron and the solder to join the already joined terminals of the lid.
We are now checking the volts accumulated by the arranged cells using the multimeter.
After what have been observed, we concluded that indeed the light emitting diode can be used to build solar panel to generate electrical energy due to the movement of electrons in the silicon crystals when struck by the sunlight.
So after the process, I learned that LEDs contain silicon crystals which when exposed to sunlight, its electrons move up and down to produce electrical energy.
We are hoping that this our project will be adopted and we will even build a bigger one. We are looking forward to sharing this our idea to the rest of our colleagues to give us alternative source of power supply, basically.